guys, welcome back to my channel. Before we get started, click that subscribe button, turn notifications, give me a huge thumbs up. Guys, today you're going to be joining on my Zoom class with science. We're going to do 5 different chemical reactions. So yeah, let's get into it. And I just muted them. Let's do this.
Next, you're going to want to get 25 milliliters of hydrogen peroxide. So I have my hydrogen peroxide here, and my graduated cylinder to measure out the solution.
Let's put it in a pot. Let's put it far. We'll let you react, Jason.
So before you toss them in and mix them together, make sure you record the temperature of your hydrogen peroxide. So I have my thermometer here, and I'm placing it in the hydrogen peroxide.
Like all the yeast is on the outside.
Yeah.
All right?
Okay.
Okay.
Well, we'll still get
So
it.
make sure you record that. My hydrogen peroxide is at 59 degrees Fahrenheit.
Hydrogen peroxide. If you want, you can follow along with us.
Okay. Then you can pull the thermometer out, and I'm going to get my hydrogen peroxide, and I'm going to go ahead and pour the hydrogen peroxide in with the yeast, and I'm going to record my temperatures to make my observations. So here we go. Hydrogen peroxide, 3, 2, 1.
You need to use this 8 times
And
to get 25 milliliters.
getting my temperature. Oh, this might
So we're
actually
gonna get gloves on
do that with
because
toothpaste.
some of the stuff can burn your skin or either
There
hurt
we
your
go.
skin.
So my temperature, I'm getting 61 degrees now. Not sure if you guys can see that reaction. So temperature after, oh, it's 63. So you can see heat is being produced. I'm gonna stir it up. See what happens. 64 degrees. 66. So the temperature keeps rising, right? So when you mix 2 things together and you get a temperature change like that, that's one piece of evidence that you have a chemical reaction going on. It's at 70 degrees now. So 1172. So this reaction is going strong here. 73. Cool. 75. So temperature keeps rising. I wonder if it's going to get. Yeah, it feels warm. 77 degrees, 79. And I'm gonna wait until I get peak temperature. Until then, I can take some questions. Yeshay?
My question is, I'm wondering if, like, sometimes I forget my question, but I have another one.
Oh, you have another one?
Yes.
Okay.
I do. My question is, I'm not doing I'm not doing it, so I'm wondering how do you get at that heat thing?
Oh, how is it getting hot?
Yes.
So the yeast is metabolizing. It's catalyzing the hydrogen peroxide and the yeast are reacting together, right? And when they come together, the temperature change is called an exothermic reaction, right? It's creating heat.
Syringes over
And right
here.
now I'm at 82 degrees. And I think that
So
might
now I'm
be
at
as hot
2.
as it's going to get.
you might need a lot more hydrogen peroxide.
I'm kind of stirring the yeast up.
Okay, that's it.
But that's pretty cool. It's warming up the bottle. Cool. Dakota, you had another question?
I'm just measuring my hydrogen peroxide.
Cool. So is anyone else getting any temperature changes here? I am at 84 degrees right now. And I think that's where it's going to settle. I should have done this in the tray. I made a big mess on the table here. Good thing I brought paper towels. Okay, so that is reaction 1. I think it was peak 84 degrees Fahrenheit.
Now I'm at 3.
There was no color change really. And there was gas released. So, based off of the temperature change, the bubbles, right, the gas that was being released, we can tell that this was a chemical reaction. So,
No, 5.
number 1 is done. That was pretty cool. I put down, see if I can take a few more questions. Scarlett, question, comment?
Question.
Yes.
I have two kids. One is in 3rd grade and the other one in 6th grade. Can they do it together, or the one for 6th grade is different?
The one for 6th grade is going to be a little different. The lesson itself will have bigger words. It's essentially the same thing, except we go deeper. Like if you look at the document for the secondary students, they are, we go into the chemical reactions and what they're all about.
Okay. So I should put her to do it separate.
Yeah, I would.
Okay. Thank you.
You're welcome. It looks like my screen share closed. I'll open it up again. Okay, while I'm doing that, oh, oops, sorry, Scarlett. Aaron, you have a question?
Yeah, I was wondering what physical science is, because my mom told me that we were doing physical science.
Oh, okay, so physical science kind of just encompasses physics and chemistry, right? Those are considered the physical sciences, or things that kind of it envelops physics and chemistry.
What are those?
So physics is the science
I'm
of
just gonna go dip this one.
movement and how things behave physically,
Okay.
and then chemistry is how things behave.
I'm going to get my yeast ready.
So like right now we're doing chemical reactions, right? So this falls under physical science. Later though, I think in a few weeks, 2 or 3 weeks, we'll move on to food science. So we'll start studying the science behind food and some of the nasty chemicals that can be found in the food supply and stuff. So yeah, that's what physical science is. Sorry, I went off a little bit there.
Okay. Thank you.
You're welcome. All right, I am the biggest Naruto fan ever. You have a question?
Can I use a meat thermometer?
That's what I'm doing.
Okay.
Okay, let's see, I'll take one more question. Let's go, mushroom. I don't think I called mushroom.
Yeah, so I'm just making sure this is okay because earlier when yours was, sorry about the background noise, when yours was about like 70 earlier, mine was about 90, and now it lowered down to 80 something, and I'm just making sure if that's normal.
Yeah, that's cool. So what was your lowest temperature?
My lowest was 85.
85, and it went up to 90?
So it was 90 at first once I put it in there.
So now that we have the hydrogen peroxide, we're gonna put in some of our yeast. I don't know if we get it ready or we put it in straight. So I'm just waiting my meter, waiting for them to go.
It did look like it, yeah. It certainly didn't smell like it though, huh? Cool.
Thank you.
You're welcome. Okay, guys, so you should record those on your table, your reaction table, and we'll move on to number 2. We're going to be doing a reaction with sugar, food coloring, and water. So, we're going to get our next container, and let's see, pour 50 milliliters of water into a cup. So, I'll go ahead and do that. 50 mLs. Figure that out. Okay.
So guys, it is slowly rising, which it should do. Hang on.
Okay, next, 2 spoonfuls of sugar.
Okay, guys. Sorry, guys. You guys just fell, but it's okay. That was just a big mistake. Okay, guys, this is probably gonna have to be the end of the video. I am so sorry. You know what? No. I could just ask my mom for something.
Alright, so it looks like I got 59 degrees. Maybe I can.
So, guys, as you can see, it is slowly rising. Slowly rising.
Sugar mixed up. Okay. It should still be 59 degrees. Yes. So go ahead and record that temperature, 59, or whatever you
It
guys
doesn't
got.
hurt to have
Your
some
initial temperature.
hydrogen peroxide.
Alright. Step 2, or the next step, step 3, pour water and 2 drops of food coloring into the cup and stir. So we're going to do 2 drops of food coloring. We'll go green.
It doesn't hurt to have a little more.
And 2. Okay. We'll stir, and we'll see if there's any temperature change.
Okay, what was the next
So
one?
mine's still reading 59 degrees. Fahrenheit. There's no gas release, but there is a color change, right? change do you guys think this one was? I'll take some hands. Mateo, Alvaro.
Hi, I'm sorry again. We ended up getting iodine and antacid. We got everything now,
Cool.
but I didn't realize we don't have a thermometer.
Oh,
I didn't know how to, but I did have them touch our jar where they did the yeast and the hydrogen, and you could feel it's warm.
perfect. Okay. It won't be as scientific, but that's okay. You noticed the temperature change, which is the really important part.
Yeah.
Okay. This is
Cool.
so weird. Why does it
So I will tell you to do it again and write down, temperature if we can, like at a later date when we get a thermometer.
Yeah, no problem.
So, sorry guys, this might have been boring, but
Let's see.
look how much it's rising.
I think I already called mushroom. Miles Morales.
I
If it's
so
not
far
rising, just
have
add a
been
little.
and my list is almost getting filled because my sheet of paper is really small.
Oh, okay.
Okay, I muted them. So, if it's not rising that good, you can just add a few more hydrogen peroxide.
This has only 5 because if my grandma goes to the store and gets everything I need, I can do all of them.
Okay, well, you could do that, but by the time she gets back, we'll probably be done with the class. You only have 34 minutes left in class.
Okay.
Okay, but you can get the ingredients and try them on your own, especially if you have the document for this week.
Yeah.
Okay.
Dad.
You? All right, one more, Selena. I don't think I've called you.
I can't do this class, and was there any gas released on yeast or on this first one?
Yeah. Oh, the yeast one. Yes, there was gas released.
Okay,
It started to fizz up
I'm
and
just
bubble.
waiting until they call me, so if you want to do
Guys,
stuff,
that means, there was gas released.
And
I know it's not like my usual videos, but it's gonna be okay.
The second and the third was 59, right?
Oh yeah, that's what I got on my recordings. I guess later when you try it on your own, you can get those readings too. So the second gas release, there was no gas release. You can see here, and I don't think there was a temperature change. It's still the same temperature. Yeah, still 59. So that is yes, color change, right? But no temperature change. Okay. Moving on to reaction number 3. Iodine and cornstarch. So,
Iodine?
same thing. You're going to get around 50 milliliters. You don't have room for that, or if you need a little more to demonstrate, that's probably going to be okay.
Milliliters.
Well, this is
Measure that out,
118,
you
so you're gonna use
cylinder.
about half of this.
Get your next container.
Should I use a measuring cup to the
You're going
half
to
mark?
pour
Nope, because it's half
the
of
water
that bottle,
into
not
a
half
cup.
the cup.
Oh, half of the bottle?
Half of the
Can
bottle.
you just mark
I think I can
where the half
use
is?
this cup.
I think I should be or something.
Okay. And then record the temperature. Oh no, first we're gonna put it in the cup, and then we're gonna get 2 spoonfuls of cornstarch into the water and stir. So again, if it says spoonfuls,
thank
it's
you.
probably not too important how much you put in there. So I'm just gonna put a half a teaspoon. Yeah, half a teaspoon.
You know what?
Half,
2
half.
So
A bottle of
really
iodine.
1 full teaspoon.
So
Gonna
you
place those
just just
in
tell your
our
parents to mark
cups. There's
the
one
spot out.
and two. So that's
We're so
1 whole teaspoon I place of cornstarch
perfect.
into the water.
2
I'm going to mix it.
2 spoonfuls of
While I'm mixing, I can take some
cornstarch.
questions.
2 spoonfuls of cornstarch. Okay, guys?
I called Everett. I called you today.
I'm sorry, I forgot to original. I'm ready to buy in.
Oh, alright. Nathaniel.
Especially so that like on my sugar and like recovery on the last like experiment that I did, mine was modified. Like my temperature was modified 3 degrees.
By 3 degrees. That's interesting. Maybe it's warm.
I have a feeling it's gonna get me,
When
so
we
I'm
put
putting
it,
it
it
on
went
the
up
tray.
when we put it closer to the sugar. When we do
Okay, that's interesting.
So that's
okay,
how
yeah,
it
make sure you
turned
record
out with the yeast and the
that. Okay.
water. I mean,
And one more, I'll take CJ Dog. Haven't called you today. CJ Dog.
no,
Did I push the button? Ask to unmute.
yeah, that's to that.
Okay, now let's go back to the top of the list. Dakota.
2 things. For the first one, the yeast and the hydrogen peroxide, it's pretty warm and it rises pretty good.
Yeah. Did you record the temperatures or you just felt it?
I don't think we have thermometers.
Well, that's okay. Did you feel the jar get warmer?
Yeah,
Cool. Yeah,
it's pretty
that's the
hot.
temperature change. When the temperature goes up with the reaction, it's called an exothermic reaction. It's releasing heat energy.
Yeah, and my second, while I was still doing the first one, I could not do the second one. So I just moved on to the third one.
Okay, yeah, and we'll do that one. Actually, we're doing that one right now. So you should have your cornstarch and water mixed together pretty well by now. And we'll go ahead and start the third one. All right, so that is enough questions for now. Let's see. So I'm going to put 2 spoonfuls of cornstarch into the water and stir. I did that. So step 3, I'm going to record the temperature of my cornstarch and water.
Sorry about the background noise, guys.
Oh, it's actually kind of cool. Wow, it's much cooler than it was. I'm not sure if that was because it was from a water bottle on the ground, but I'm recording it. So mine says 61 degrees. Oh, actually that's warmer, right? 61 degrees Fahrenheit because I've been recording 59. All right, so I recorded my temperature. And next I'm going to use a dropper to add 10 drops of iodine to the solution. So I'm going to go ahead and put my solution in my test tube here. Alright. And I'm going to get my iodine, which I just purchased. Should have opened it before class.
Yeah, so just
I'll
that's
do it
like
now.
the half.
While I'm opening it, I can take a question. Carolina. Question, comment, observation?
I don't have iodine.
Oh, okay. Then just skip the third reaction. we can do the fourth one together.
Okay.
Alright, so here we go. I got my iodine. Not sure if it's mixed or whatever. Okay, so here's the solution, and we're going to add 10 drops of iodine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So check that out. The iodine and the starch, the cornstarch, are
Oh my God.
reacting,
Oh my God.
and we're getting a color change. I'm going to go ahead and stick my thermometer in and see if there is a temperature change. I have 63 degrees. So it looks like the solution went up by 2 degrees. That's interesting.
Wow.
No gas release. There definitely was a color change. Mine turned purple, like a really deep purple. Pretty cool. So just based off of that, you guys think this is a physical or a chemical reaction? You shake?
I'm thinking, what do you use for that heating thing? What do you use?
For the heating thing?
Yes.
Oh, so some solutions, when you mix them, some mixtures will actually release energy. So I'm not doing anything to change the temperature. It's the solutions themselves that are reacting and causing it to heat up. Pretty cool.
And I have another one.
Yeah.
And are we gonna have another class after, or
It'll be the same experiments, but it's going to be at the secondary level. So I'm going to go into the actual chemical reactions and stuff.
another class like this morning?
Oh.
No, the class like right now. Do you have a
I
class?
think Mr. Brett had his.
Yeah.
Yeah, he had his this morning, just before me, and
Yeah.
I'm after him. I think it's just us two, yeah, on Wednesdays.
Okay.
Okay.
That's it.
No, that's okay. Let's see, Jamie. Actually, I haven't called Merrick, Alaric, and Sage yet today, have I?
Mom, see you.
Ours was 79.
Mom, see you.
Ours was 69, and then it went to
All of these experiments are making me hungry. Mom, see you.
Our color of it when we mix it all together,
Just ignore the background noise.
light lavender.
Oh, lavender. That's cool.
We just had a swab. We had a swab. So,
Oh, a swab with iodine on it?
yeah.
That's cool. Yeah, that's probably why mine's super dark.
Sorry, that's just my sister and my mom playing.
Yeah.
Cool. Okay.
Little Thunder and Mom Thunder.
Thank you. Good. All right. And finally, Jamie, and then we'll move on to the next reaction.
Oh, and I will be making a YouTube video about me trying out the new Mario Kart 8 Deluxe. So you guys want to see that.
Two of them change color?
Change.
So which ones are those?
Sugar water. Didn't do anything. It just changed color.
Yeah.
Iodine and cornstarch. That's physical cooking water. Even though I didn't do the cornstarch. I had cornstarch.
Did it react? Can you show me your solution?
We
Oh, you don't have it.
don't have iodine.
Oh, okay. Yeah. I had to order mine too. I didn't have it on hand either. Even though it's really good for you, iodine.
Yeah.
Yeah. come out purple like this. Somebody put just a swab of it in there and it turned it lavender. So the starch and the cornstarch and the iodine, they changed color. Now that's what's, it's not really the chemical reaction. This is also a physical change, right? This is an indicator. So iodine is an indicator for the presence of starch. They don't actually mix. It's pretty interesting stuff. I'll go into more of it if you want to learn more about that kind of reaction in the next hour. Okay. I got two more hands. I guess I can take on Dakota.
Sorry about the background noise. So
That's okay.
for my first one, the yeast and hydrogen peroxide, it turned like this snow white color.
Interesting. Yeah, mine looks like oatmeal.
Yeah, mine kind of does too.
Oh yeah. Cool.
But I can tell you one thing, it smells really bad.
It does, yeah, that's that yeast. Thanks, Dakota. All right, last question, Carolina.
Yeah, guys, do not smell that yeast. It smells really bad.
So I don't know if I can do the fifth reaction.
Oh, it's okay. We're gonna do the.
And I was wondering if I could show the class I remember a volcano after the fifth reaction.
Oh, actually, is it a volcano made with baking soda and vinegar?
Yep.
Oh, okay. That's actually what we're about to do. So
Wait,
yeah. So we'll do that one together, okay?
yeah.
Okay. So,
Wait, I just have to move it to class over here so they on my porch right now.
okay.
That's
So
why I didn't do it
we'll do it after, okay? So save it and we'll show the class, okay? All right. So let's go ahead and get her started here. So reaction number 4, baking soda and vinegar.
Baking soda.
So we're gonna put 2 spoonfuls of baking soda into a cup. Where is my baking soda? And I'm gonna dry my spoon here. I'm gonna grab a spoonful, place it in the cup. Another spoonful,
Pretty dry.
and place it in the cup. Alright, or test tube for me. Next, we're gonna get 50 milliliters of vinegar. And before I pour it in, I'm going to record the temperature of the vinegar by itself.
Mommy?
So where is my vinegar? There we go. And 50 mLs. So that's where you'll need your graduated cylinder. Or if you have another way of measuring out 50 mLs. It's not too big a deal. This time, for it to be exact.
Okay, good. We're going to measure 50 milliliters of cornstarch. Wait, no. Not cornstarch.
Okay,
Vinegar.
so there is my vinegar. I'm going to record.
So you're gonna do 3 tablespoons.
3 tablespoons.
So thermometer in,
Mommy.
and we've got.
Okay, guys, I got 1 tablespoon.
Okay, so from there, you're going to pour your vinegar into the cup. I would do this one on the tray. I think you guys know what's about to happen. Alright. I guess before I pour a mushroom, you have a question or something? crazy reaction. If you've ever done your basic volcano chemical reaction, that's baking soda. This is definitely a chemical reaction. It's
Hey,
called
mommy, come
an
on, touch me,
acid-base
Come on,
reaction, right?
touch
The
me.
acid is the vinegar.
Hey, mommy, come
The
on,
base
touch me.
is the
Hey, mommy, come on,
and
touch
when
me.
we mix them together, we undergo a neutralization reaction.
Hey,
Like
mommy,
so.
nana, boo, boo, nana, boo, boo, ba, ba, ba.
They undergo a neutralization reaction, and they do this, right? Carbon
Hey, Mommy.
dioxide is being released.
Hey, Lily, want
Salt
to
is
taste
being
one?
created
No, it's
inside the
yucky.
solution.
Hey, mommy.
Pretty cool stuff.
That,
Alright, oh, I forgot. Looking for the temperature.
Can you hold me?
Oh, that feels
Can
cold.
you give me
It
some?
went down in temperature.
Can you give me some?
I'm getting
Please.
54
Can
degrees.
you give me some? Can you give me some myself?
That's interesting. So that went down in temperature, 54 degrees Fahrenheit. So it went down 5 degrees. I lost 5 degrees of temperature. So when that happens, that's called an endothermic reaction, right? So a couple of the reactions that we had, especially reaction number 1, heat was produced, right? That's called an exothermic reaction. You feel the heat. An endothermic reaction is the opposite, right? So an endothermic reaction is going to use energy. So it's using the energy and taking it from the two when they mix, and it's causing an endothermic reaction where it steals heat. I guess you can, you could say it steals the heat and uses it for the reaction. So endothermic reaction. All right, Miles, question, comment, observation?
I actually did a volcano with my mom and my brother and my sister, and we built like a whole new
Go get your
volcano.
soup, you drink your
Yeah, those are fun. I think we did that this summer together, also as a class. Who was it that was going to show their volcano reaction? I kind of want to see that. Any other questions, Miles?
No, I actually was waiting to see what was gonna happen and what the temperature was gonna be.
Yeah, I lost 5 degrees Fahrenheit, so that was pretty cool. Let's move on. North Dakota.
So for the fourth one, mine did not go up as tall at all. It just went up like half of the cup, not even.
Oh, really?
Yeah.
Interesting. No, mine poured out. Look at that. I only have this much left.
Wow.
Like 10 milliliters. It all just exploded. Cool. Well, make sure you write that observation down. So, was there gas release? Yes, definitely. Color change, not really. Temperature change, yes, right? There was definitely a temperature change. I lost 5 degrees Fahrenheit. All right, so on to the final reaction, reaction number 5. Reaction number 5, so let's go ahead and get that started. We're gonna get our container, place 2 antacid tablets into a cup. I have my antacid in a powder form, so I'm gonna use that. So Alka-Seltzer or any of those will do. That's about tablet one. Then you're going to measure 50 milliliters of water and record the temperature. So, in my graduated filling, I'm going to measure 50 mLs of water, maybe a little less because that was wrong. Okay, and I'm going to record the temperature. Record the temperature of your water. I am at 59 degrees. Make sure you record those. Mushroom?
Yeah, so mine didn't really do anything. It just turned the water into a bit foggy. And it just the color that the tablets were.
Oh, so you put some fantastic. This is number 5 for you?
Yeah.
Okay. Did you see any fizzing or anything?
No, not really.
Interesting. Alright, well, let's try mine out. So, I'm going to get my antacid, and I'm going to go ahead and pour in the water and record the temperature. Here we go. Okay, so that's a lot. I might have poured it too fast, but that's, let me go ahead and record the temperature too. Oh, that's cool. That's cool. Yeah, 52 degrees. So there was definitely a temperature change. There's definitely gas release. No color change. Lots of bubbles.
Nothing happened.
No.
Oh, I'm down to 48 degrees. Wow. 46,
Oh, maybe because we
43.
don't see the temperature. That's what's changing, is the temperature.
That's huge. 41. So this is definitely an endothermic reaction.
Whoa.
That reaction used up a lot of heat. So 41 degrees is as low as mine got. Pretty cool stuff. I may have put too much antacid. But that's cool. We got what we needed, right? We got that temperature change recorded, which shows that there was an endothermic reaction. So that is definitely a chemical change. Alright, so after you have all your data recorded on your table, now you can scroll down here. This is what it would look like. This is what you would fill out. And then, now that you have your data, you can put whether you think it was a chemical change or a physical change. And then you can use your data to support your hypothesis on the right, right? So, what do you think? Right? Was it a physical change or a chemical change? If you're still unsure about that, you can go back to last week's lab, where I explained the difference between physical changes and chemical changes. Okay. Wait, how do I have my hand raised? Oh, wait, weird. Alright, Janet.
We had a meeting.
You had the what? Oh, you had the lead? Oh, okay. Did you do any of the experiments?
Yeah.
Oh, cool. And how'd it go? Is there anyone that you liked in particular? Any reaction? Oh yeah, that one's always the most fun, right? It's when we do the volcano with that one. And it's an endothermic reaction, so it actually got pretty cool. It lost 5 degrees. The antacid lost a lot. The antacid lost 18 degrees. So it went down 18 degrees, which is pretty interesting.
Okay, we're just gonna let you know we're
Hey,
hungry.
Mr. Man,
Oh, that's okay.
the other house, that was me.
Oh, okay. Yeah, that's okay.
Bye.
Bye.
Bye. Okay. Let's see. And Dakota. Question, comment, observation?
Why do you have your logo in? What would you like to change it to?
And I'm still waiting for that volcano.
To that?
If you guys, I forgot who was gonna do the volcano for us.
So, ours didn't really do much because our, inside passage are old. They were left up in the attic. But most part, the water changed color and they're starting to lose their color.
Oh, okay. Well, that's all right. You know, we work with what we got.
Yep, so bye-bye.
Bye-bye. Okay. Let's see. So that was 5 chemical reactions, 5 reactions. Now,
Well, that was not really fun, but good. Oh, sorry guys, I forgot you were here. So, if you liked this video, make sure to comment. What was your favorite experiment? Make sure to give us a like. And please subscribe. And I will see you in the next video.